Imagine running a school using only sticky notes. You've got student names, test scores, and addresses swirling around in a giant, chaotic mess. In Python, a basic variable is exactly like one of those sticky notes. It holds just a single piece of information, like one student's name. But if you have 50 students, writing 50 separate sticky notes gets messy fast. To make sense of it all, we need something bigger. We need a filing cabinet. In programming, we call these filing cabinets data structures. They give us a way to organize, sort, and search through massive amounts of information easily. Gathering the information is only step one. Picking the right type of container for that information is what turns a messy pile of data into a smart, efficient program. First up is the list, which you create using square brackets. Think of a list as a flexible student roster. The computer assigns everyone a spot, starting at 0. So the first person is at position 0, the second at 1. Lists are flexible. You can add a new student to the end, remove someone, or grab a specific slice of the middle. But you might have information that should never, ever change. That is where tuples come in. You create them using parentheses, and they act like a list that has been permanently locked. If you try to swap out a student's finalized ID number inside a tuple, the program simply rejects any attempt to change it. This built-in security prevents accidental edits. If your data is going to update over time, put it in a list. If it needs to stay perfectly secure, lock it down in a tuple. Now that our data is stored securely, we need a way to make decisions with it. Enter conditional statements: if, elif, and else. Think of these as a bouncer at a door, asking questions and directing traffic based on the answers. This diagram shows a grading system evaluating a score of 85. The bouncer asks, is this 90 or higher? No, so it moves to the next check. Is it 80 or higher? Yes. The score drops safely down into the B grade bin. You can stack these checks to handle all sorts of logic. Check if a number is even, or if it is odd, by checking division by 2. Or compare 3 different scores to see which is highest. Lists and tuples are the memory of your program, but these conditional statements are the brain. They do the actual thinking. Sometimes a simple list of items isn't enough. If I give you the numbers 98, 97, and 95, you don't know what they mean. Dictionaries fix this by giving your data context. They use key-value pairs, where a descriptive label, the key, is attached to a specific piece of data, the value. This image shows how a dictionary is built using curly braces. Inside, there's a label in quotes, a colon, and the actual data. Ask the program for the CGPA key, and it goes straight there to hand you back the 9.6. This image shows that you can even put a dictionary inside a dictionary. Here, the score key opens up a completely new set of labels for chemistry, physics, and math grades. The final container is the set. Sets also use curly braces, but they don't have labels. Instead, sets have one ironclad rule: every single item inside must be completely unique. Because everything in a set is unique, you can do math with them. You can use the union command to combine 2 different sets into one big group, or use the intersection command to find the exact overlap between them. Dictionaries organize complex data by putting a clear label on it, while sets act like a filter to guarantee you never have duplicate information. When you are just starting out, it is easy to make a few common mistakes. You might forget that lists start counting at 0 instead of 1. You might try to change a locked tuple, or you might try to put a changing list inside a set, which sets simply do not allow. Let's look at a real-world problem. Imagine you have a massive list of classes all the students signed up for. Math and history appear dozens of times. If every unique subject needs its own classroom, how do you know exactly how many rooms to book? You could read the whole list and tally them up by hand, or you could solve it instantly. Just pass that messy list into a set. The set automatically deletes every duplicate, leaving you with exactly the number of unique classrooms you need. To keep it all straight, remember the symbols. Square brackets are for lists, parentheses for locked tuples, curly braces with colons for dictionaries, and curly braces alone for sets. Learning which symbols to type is the starting point, but the real advantage comes from knowing which container fits your data. When you choose the right structure, your code becomes organized and easy for anyone to understand. Try it yourself by opening your code editor and building a dictionary for your favorite movies.